Well, hello, Algebrainiacs. Welcome to the Johnson-Kendrow Video Hour.
But it's not an hour!
No, but sometimes I bet you wish it was. All right, today we have for you systems of inequalities. Systems, remember, is used when you have more than one equation. And this time we're doing inequalities. So, we're shading again, and we're finding the overlaps. Let's try these two that we have right in front of us. This first one, x plus y greater than equal to, or just greater than 3. We want to get the y alone to be able to graph it easily. So let's subtract x. Y is greater than negative x plus 3. So now we go ahead and graph that. Go up 3 right here, and then down 1 over 1, down 1 over 1. And then we connect our dots. Oh, I already made a mistake. Back it up. I have to do dotted line because it's not an equal to. All right, as far as shading, this says greater than. Greater than means shade above. Now I'm just going to show some little bitty shading here because if you start doing too much, it gets a little crazy and then it's hard to tell what's what. All right, so for the next one, I'm going to do this. Now it's already in the correct form, so let's go down 1 and then up 1 over 1, up 1 over 1, up 1 over 1, etc. Okay, we have greater than, so again, a dotted line. It's greater than, so I'm going to shade above. Now, can you see where the black and the red are both overlapping? That's where we want to color it in nice and dark. Get a little anger in there if you want.
You're mocking me!
But that's the easier way to do it than trying to get scribbles everywhere. Then you just have one little spot. Okay, the next one. This is in standard form. So if you choose, you can do the intercepts, which I'm going to do, because really it's a lot easier. So if I choose 0 for x, that makes 0 minus y greater than or equal to negative 4. Divide by a negative 1 on both sides to get y by itself. That flips that thing around, so I just get y greater than 4. Now we don't really care about the equal sign or the less than or greater than, it's just going to be the 4. All right, but it has to be shaded too. So, all right, we're gonna do that later. Let's find the other point right now. So if I put a 0 in for y, I'm going to bring the 0 over, which I don't really have to do, but I'm going to divide by negative 2, and x less than or equal to 2. We don't care about that right now. We just have 0 and 2. All right, so now we're going to plot those two. 0, 4, and 2, 0. It's a solid line. I didn't make my line very good there because my shadow was in the way. So I'm going to back up and try that again. And to think I never had an art class. Who would have figured? All right, now as far as shading, remember we said don't worry about the greater than or less than. We have to test a point. We're going to test 0, 0. We're going to put that into the equation or the inequality and test it and see. So if I put a 0 in here and a 0 in here for y, is that greater than or equal to negative 4? Is 0 minus 0 greater than or equal to negative 4? Yes, I do believe it is. So that means we shade on the side of 0, 0. Okay, now we have to graph the other point. X is greater than 3. Now if x were equal to 3, we'd have all these dots right at the x equals 3 mark. So I have to put my dotted line there. And because it's greater than, bigger numbers are to the right, so we shade to the right. And can you see where the overlap is? I can. Can you?
I can.
All right. So let's shade that in dark. And there we go. So remember, with the greater than or equal to's, you don't have to worry about them until you choose that point 0, 0. Then shade whichever side you need to.
And that was because it was standard form.
Because it was in standard form, yes.
All right, here is another one we're going to do. This time our first equation, this is kind of like the one Mrs. Kendrow just did. It says if we thought about it saying y equals 4, that would be a horizontal line because this time all the y values are at 4. It is dashed or dotted because it is not equal to, and we're talking about y values that are greater than 4, so that would be shaded above. And then our second one, you'll notice, has those absolute values on there. So we're going to have to go through those steps. Remember that the -2 means that this is going to go to the right 2 because it's on the inside. The +1 means it's going to go up 1, and I'm going to deal with those last. What I want to do right now is make that shape chart for just the beginning part, and you can pick easy stuff here. And if I plug those in, I'm going to get 0, 2, and 4. That would look like this. And we can use symmetry to reflect on the other side. But remember, there's a shift going on. I got to move each of those things right 2 units and up 1. Right 2 and up 1. It's going to look like that. This one is equal to, so it will be solid. And it is less than, which means the shading is on the outside of the V. So this does get a little more complicated when we have the absolute values in there. So you have to find the areas where our blue shading and our green shading overlap, and it's right in here. It's got to be above the blue line but outside of the V. Angry shading. Okay. We cannot shade inside the V at all, so that's why that piece is just kind of cut out of the shading. So last thing we're going to do, we're going to write our own systems. So this kind of goes along. We've been doing writing your own systems with equations. This is just going to be inequalities. So here's the situation, a pizza parlor, and we picked pizza because Mrs. Kendrow really likes that pizza.
Very much. I like chocolate shakes too, but
yeah.
They don't have any here.
Right, so pizza parlor charges $1 for each vegetable topping. Who likes vegetables anyway? And $2 for each meat topping. You want at least 5 toppings total on your pizza, and you have $10 to spend on toppings. How many of each type of topping should you get on your pizza? So remember, I have those hints over there. We need to identify what the variables represent. I want to let X be the veggie toppings, and that's representing how many of each type we're going to have. And then for the Y, we'll do those as the meat toppings. Okay, so I've got some limits going on. I see at least 5 toppings total. And if I wanted to find the total number of toppings, my first inequality, you'd have to take the number of veggies and the number of meat toppings, and at least implies greater than or equal to 5. So that's what one of my equations is about, the total number. The second equation is going to have to be about money. I have $10 to spend, so that's going to be my total at the end. And if I have $10, can I spend 11?
Only if you want to wash dishes.
Okay, so could I spend exactly 10?
Yeah.
And how about less than 10, like maybe 9 or 8 or 7?
Sure, then you could leave a good tip.
Right, so less than or equal to 10 is what we're looking for. We spend $1 for each veggie, so that's going to be 1x, and then $2 per meat topping, so that's going to be 2y. We need to graph our equations now. Those are our equations. I'm going to put them to, well, actually, let's do it the intercept way. For the first one, I'm going to plug in that 0 for the x, just like Mrs. Kendrow did. If I do that, I'm going to get a 5. This one's pretty simple. If I plug in a 0 for the y, I'm also going to get a 5. So it's going to cross at 5 and 5. It's like a giant graph. It's solid. And I said greater than, so it would be above. No, I can't assume that. Thanks, Mrs. Kendrow.
My pleasure.
All right, so we got to test 0, 0 because I use the standard form. That's why. So if I plugged a 0 in here and a 0 in here, I want to know, is that greater than or equal to 5? Is 0 plus 0 greater than or equal to 5?
No!
No way, Jose. So that's how I know that I'm going to shade above. You cannot just assume. Also, how come we're just using that first quadrant?
Because it's money.
It's money and it's toppings.
You can't have negative toppings.
Can't have negative toppings or negative money, so I'm going to have to stay within that first quadrant. All right, let's do the second one. This time I'm going to do the intercepts again, so if I plug in a 0 for the x, that would leave me with 2y, and you can pretend even that's an equal sign, equals 10. I would divide by 2, I'd get the y-intercept at 5, so that's 1 point. Then I'll do it again the other way, putting a 0 for the y, I would get 10 for the x. So the y-coordinate is at 5 again, and that x-coordinate is going to be at 10. And I'll connect those. So we'll connect that. It's going to be a solid line. Now let's talk about the shading. I did the standard form thing again, so I need to test using 0, 0. If I have 0 plus 2 times 0 less than or equal to 10, I'll get 0 less than or equal to 10. That's true. So on the black line, I'm going to have to go below. So the overlapping area is in this pizza slice. And notice I'm stopping in the first quadrant, 0 and 0. My x and my y-axis are boundaries as well. So that shaded area represents the possibilities for our toppings. All those points in there. And actually the next lesson that we do has to talk about how that's called a feasible region. So, all right, we're going to hang out and eat some pizza.
Okay, give me the anchovies.
All right, we'll see you guys in class.